Good morning, everyone. My name is Greg Jonas. I'm the Deputy Division Director here in Facilities. We're going to have our all-hands safety meeting today. The result of recently we had a couple incidents in facilities where we had a couple of our workers get injured. Although the injuries were minor, the consequences could have been much more difficult. So we are fortunate that they were minor, and we're going to share some of the lessons learned from those incidents with everyone in the division today. Today's agenda, I'll start with the opening remarks. John Banker will talk about some of our safety trends. I'll go over the trickling filter event. Chris Jablonski will go over a boiler house incident. Sue Brennan will talk about heat stress. Quinn Matula will talk about glove use, and Steve Spangler will talk about material handling. And then I'll wrap up the session. So the first thing, and actually the most important thing, is your safety is the first priority. Safety takes the precedence over everything we do. We never ask anyone to do anything that would put yourself at harm. When we talk about these incidents, one of the examples that happened, someone did put themselves in harm's way. Fortunately, the injury was minor. Situational awareness. In both of these instances, conditions changed during the events. In one, it was weather coming in, so off shift was responding to a weather event. In the other one, it was in the boiler house. There was a change in operations with the combined heat and power plant, and it caused us to react to that change. So always be aware of changing situations when you do work. Situational awareness, that can put a different spin on the work that you're doing. Safety is a partnership. Everyone here is responsible for your own personal safety. You're also responsible for the safety of your coworkers. You'll see in these events that actions by coworkers reacting to the events helped make these events minor and not as severe as they could be. We want to dial 911 not only for emergencies but also for notifications. It can be used as a notification system. If you see something and you don't think that you want to roll out the fire trucks, let's say as an example, someone might hit a stop sign, the stop sign might be bent over, you see it, you can call 911. Get it in, it will bring the right people out to the event and be able to remedy the situation. So if it's a notification, you can simply say, I just want to make a notification, but still use 911. Obviously, use it for injuries or anything when there's an impending condition where you need help and we need resources, dial 911. If on your cell phone, it's 630-252-1911. And lastly, we've talked about this before, everyone has stop work authority. From the lab director on down, everyone has the right to use it, and you should feel comfortable using it. You know, we have our work crew sessions on Thursdays, myself and John Bush, and we talk about this. And I can tell you recently, it was a Sunday of 4th of July, some of you may have been aware of it. We had a power outage at the Argonne Guest House. So we had a limited crew here, building maintenance, utilities, off shift, and a number of people supporting the entire emergency operations center. And with that transformer and that power outage, building maintenance foremen, the mechanics, they stopped and paused several different times while they were doing their troubleshooting to make sure that the work was being done safely. We took a really cautious approach, and in the end it was successful. The guest house was powered up on Monday, and normal operations started happening on Tuesday. So it was a collaborative, working together as a team, and that's really what it takes to get the work done here. And as I've said in some of the work crew conversations, it takes everyone here in order to make this lab operate. And you have to work together in order to be successful, and we'll talk about that today. So next up will be John Bankert, and John will talk a little bit about some of the safety trends. There you go, John.
Good morning. Probably the last thing I would want to talk about on an early morning is safety numbers. So I figured out, hey, if we use a different term than safety numbers, maybe it'll have a little more interest for us. So we call it trending analysis. How many of you heard trending? And how many sports fans are there out here? How about baseball fans? Yeah, what have you heard in baseball lately? Last couple of years, all we've heard about is sabermetrics. And this is where every swing, every pitch, every fielding condition is analyzed. Even something called launch angle. You heard of launch angle? All right, that's for home runs. People talk about the juiced ball these days, but really it's all about the sabermetrics. And so if we use the term safety metrics, it sounds a whole lot easier than just talking about safety numbers and how bad we've been or whatever. But if we looked at the trend analysis here, you can see actually we're doing fairly well. If you look back over here, 2014, we had 14 serious injuries. What's a serious injury? Anything greater than first aid. So if you end up with some sutures, loss of consciousness, prescription meds, that's a pretty serious injury. That's greater than first aid. So out of our IS group, let's go back. Out of IS, we had 14, dropped down to 8, bounced up a little to 12, and this year, through 3/4 of the year, we've had 4. So if we look at this and say, hey, how are we doing overall? You can see the trend line, nice green line, is pointing downwards. So our metrics are pretty good for serious injuries over the last few years. Let's take another look at this to verify if what we're doing serious injury-wise, maybe somebody's decided not to report something. Let's see if we can look at the number of incidents that we end up logging over a period of time. So I had these numbers back to 2016, 17, 18, and again through 3/4 of this year. Back in 2016, we had 6.75 incidents logged per month. You can say, how do you get a 3/4 of an incident reported in a month? We're looking at the full year divided by 12, and that gives us our incident rate per month. The following year, 2017, we dropped down to 2.25, bounced up a little. If you remember, we bounced up in our serious injuries in 2018. We had 6.5, and this year we're actually doing fairly well, 6.2. So overall, we've had 2 trend lines here showing pretty good results for the IS Directorate. So Greg mentioned we've had some serious incidents in the last month or so. What's this trend line look at? Ooh, we got a red line there. That probably indicates not too good. But if we look at this year, this is for 2019, fiscal year 2019, we went 4 months with no serious injuries. And with IS and a group of 600 people and the work we do, that's darn good. But before you strain your back, giving yourself a pat, take a look that in January, we finished the polar vortex. February, we did sustain 1 serious injury, dropped back here to 0 for 2 months. And then what Greg was mentioning, we have had some issues here in the last 2 months. Perhaps we're thinking a summer, I don't know. But we did have 1 serious injury in May, and then we had 2 in June. July isn't in, but I hope we can bring that back to 0. So our upward trend here for the last couple of months has not been good. And that's why top management looks at, if you will, safety metrics also. And they've said, I think you folks got a little bit of effort in front of you. So I'm saying make sure that you use your ISM principles. And those are what? First of all, plan the job, know what the job's going to be, identify whatever hazards are there, put the controls on it, perform the work within that particular task that you've outlined. If it creeps a little bit, and everybody has scope creep periodically, you pause the work. Again, like Greg mentioned, re-identify the hazards, put the new controls in place, and proceed through with the job. Complete it successfully. I know we can do it. We've done it in the past, and for the last 3 months of this year, the summer months, let's see if we can get back to fully utilizing that and reversing this trend line from red back to green. So thank you very much for this attention. Next slide. Oh, there was one that got put in here that I didn't put together, but Greg has asked me to talk briefly about it, and that is, if we look at, again, safety metrics, we can see what areas we've been having problems with. I'm sorry, I hit that again. Government vehicle incidents. Boy, that's a real bugaboo, I'll tell you. It doesn't take very much to rack up $1,000 on any of our vehicles. Is Dawn around here? Dawn Farazi? Dawn will tell you, she hears of all these incidents. She has to make the arrangements for repairs. It's very easy to rack up $1,000 by backing into something, even though vehicles are pretty much equipped with backup alarms and the visual indicators. Kind of a funny, well, I shouldn't say funny, but one of the scenarios we had, not with this division, was the individual parked a rather large truck. Somebody pulled up behind this individual in a small sedan. The driver of the large truck came out. Again, not anybody in FAC. The individual backed right into the van. When questioned about how did that happen, the individual says, well, I drive an old car and I don't have any backup alarms or anything, so I just don't bother to look at them in these big trucks. But it costs probably about $1,500 to make the repairs on that. Injury-wise, we have things like sprains, 12%, struck by or struck against, another 12%, slips and falls and trips, 20%, exposure to substances or environmental conditions, 12%, and things that are small portions that make up a total of 20%. So here are the key areas again: government, slips and falls, and 12% for this group. So now you know all about safety metrics. And with that, I'll turn it over.
Thanks, John. So one of the things that's important going into the last quarter of the year is we have a lot of work, and you know here in facilities, it tends to become our busy time of the year, trying to get projects done. We have year-end money. There's a lot of deliveries coming in. A lot of the researchers want their products delivered, so it becomes a busy time. So as John said, we want to keep that red line down and just be cognizant over the next 3 months. And we have other conditions, you know, Sue Brennan will talk about the heat stress, and this week is going to be a difficult heat. So with you and your supervisors, you should have work plans into place this week in order to avoid anyone getting heat stress. So I'm going to talk about the trickling filter event. So this occurred on Monday of Memorial Day. So the lab was closed. We always have a skeleton crew here of off-shift mechanics. We are a 24/7 lab here, so we always need someone supporting the lab. And fortunately, we have off-shift and we have mechanics on site. So we had a wastewater treatment operator enter one of our trickling filters. It was a confined space, but without following confined space procedures. The trickling filter is building 574, and I'll show you a picture of it. It happened in the afternoon. They knew a storm was coming in. The wastewater treatment operator was trying to do the right thing along with the off-shift mechanic. You know, we just have a handful of people. This is a large site, and trying to get things prepared for the storm. So he went into the trickling filter to open a gate so that we don't flood out the sand beds. And there's a rotating arm. I'll show you a photo of that. And he slipped and he fell. The arms rotate. He's trying to stop it. They typically stop it manually, and that's what he was doing in this case. But because some of the water pressure in that, the hydraulic water pressure in that arm knocked him over. The other thing that, that happened is when he went in there without, he went out in alone, so it was a confined space. So you know signage throughout the lab, there's a lot of hazards, chemical, biological, confined space, radiological. There was a sign on the door that said there was a confined space, but there was a practice in that group. They felt comfortable of going in that area, and under this condition, somewhat of an emergency and urgent condition, he went in there. This is a photo of it. So this building right here is where the trickling filter is. This is what it looks like inside. So this is the arm that the wastewater treatment operator tried to grab on. There's a little appendage here to stop that from rotating. You'll see some holes in here. The wastewater trickles through those rocks. The rocks are a little slimy because they're doing their job to break down the water. And he slipped on the rock. He actually went into, we have 2 trickling filters. And you know, he did call his foreman and said, I'll take care of it. He was trying to do the right thing. But one of the lessons that we're going to talk about here is he put himself at risk, and he did get injured. Not only did he get injured, then he went back to his locker room, took care of himself, and he went to medical the next day. They did not call 911. So this is, you know, we call 911 here for a lot of things, and we talked about it when we had the utility session, which was about a week ago when we met with that group. You know, people called for a number of different things, and as a matter of fact, on June 12th, someone called it for a bird falling out of a tree. And you might think that's, you know, maybe, you know, why did they do that? Because they wanted the USDA, which we have on site, to take care of the bird that fell out of the tree. So again, to get the right response here. So this is the building. Oh, sorry. This is the building, there's the door. You know, one of the things that we're going to do from a lesson learned is get the confined space on the outside of the door. You actually don't see the sign till you open the door. Probably not the best setup here. So some of the things that went right, you know, the mechanic wanted to take care of it. He was trying to do the right thing. Talked to his foreman, said, I'll take care of this. You know, again, we're on a skeleton crew. Foreman's running over somewhere else to get a pump in place so that another pit didn't flood out, and we're really kind of in a scramble mode. By opening the gate, we didn't flood out the sand beds, so we didn't really have an environmental discharge. They did a couple of the other things. They did check the weather. They knew the weather was coming in. It came in a little quicker, and they did open the dump gates. Some of our corrective actions is we really need to look at our procedures for off-shift. There's things that we can do. It is a big lab. We do have other resources. You know, no one here should ever feel they're alone or on an island. We're a big enough group in facilities. We have over 300 people in facilities, 200 frontline workers. We also have the resources of protective force. So like on weekends, you can contact them and say, hey, I'm going into this space. I'm here by myself. We also have the fire department. They're confined space trained, and they can also help out. On the weekends, we have the weekend custodial crew. so they're here. So we have a lot of resources. We want to utilize those resources. A couple of the other recommended corrective actions. Why did this person do that? Because it was a manual operation. He had to go and open the gate. So we're going to look at automating that so we can take that out of the system. We're also looking at the confined space for that building, analyzing it and see if that's the right signage that we need. Maybe it's a confined space, but maybe not permanent confined space. We're looking also at solutions to develop a walkway inside of that filter so you don't have to walk on those rocks. But really the most important thing, and this is that safety is the most important thing. It takes precedent over anything we do here in facilities. Never do we want to put anyone at work. Never should you feel that you have to get something done because, you know, it's part of my job. If you feel that you're putting yourself at risk, stop and call. Call your foreman, call your supervisor, stop the work. One of the things I want to talk about with confined space is I found a report that was put out by the National Institute of Safety and Occupational Health, and it talked about confined space. So in this case that we had today, this person ended up with the person slipped, scraped their knee, and they had a first aid. It could have been much worse. So on average, there's 100 fatalities a year from entering in a confined space. They did a study, they looked at close to 670 confined space deaths. And one of the things that they found in only a third of those cases did they have a procedure. And in those third of the cases, they didn't follow the procedure. Well, Argonne had a procedure in this case, and we didn't follow our procedure. Fortunately, it was only a first aid, but it could have been more catastrophic. 75% of the time that people go into confined space is for maintenance and repair. So that really applies to us a lot. That's usually the only reason we go into a confined space. So when you go in that space, you're potentially putting yourself at risk. In those cases of death, the same as here in Argonne, 0% of the time did anyone check the atmosphere before they went into that space. So there is a common thread with years of research on confined space, and we fall into some of those same categories with this incident. So if anything comes out of this, don't put yourself at risk. Pause, stop, and if you need help because you're by yourself, you might be, if you're a grounds person and you're out in the woods cutting a tree or something and you need help, call 911, get the fire department there, call protective force, or you can call somebody else in the division. Never do we want anyone to feel that, hey, I have to do this because it's my job. We don't have that kind of pressure here. We're not a production facility where we're saying you got to do 100 widgets an hour and we expect you to do 100. Argonne's very fortunate and generous in that we understand that safety is a priority. We live it here, we preach it, we talk about it weekly, and we want to make sure that we follow it. So I think next I'm going to give the stage to Chris Jablonski. Chris is one of our facility engineers in the boiler house. Chris is our subject matter expert on the boiler house from an engineering standpoint. He's going to talk to you about another incident. Fortunately, it could have been more dire, but again, some actions were taken by coworkers and the people that were on scene and helped to alleviate the seriousness of the injury. Chris?
Hello. So I was asked to discuss the incident in the boiler house, and as Greg said, it's very fortunate that the individual is okay now. But on June 24th, and forgive my operations here, I'm new at this. On June 24th at 4:15, we had boiler feed water basically discharged out of a boiler feed pump when one of the seals broke, striking one of the workers, and that resulted in first and second degree burns. The reason this happened was there was a chain of events, like Greg said earlier. The CHP boiler ended up tripping off, causing our number 6 boiler feed pump to speed up to try to make up water. That ended up tripping off. So operations ended up scrambling to put on a second pump. They went to number 4 boiler feed pump, and in the process, the foreman and the operators ran down there to line up the pump, get it ready for operation. They ended up putting the pump on, and in this case then, one of the 2 shaft seals, the bolt was so corroded that it broke off during that process, allowing the boiler feed water to come spraying out and actually hitting the worker. So here's a picture of, I get the laser right. This is the motor on the boiler feed pump. The boiler feed pump itself is over here. So on this side, this is the inboard seal, and then the other side is the actual seal that failed. And here's a welding blanket that they ended up throwing it over to knock the spray down. So this is the inboard side seal. Here you can see one of the 2 bolts, and here's the other one that actually hold the gland collar in place. On the other side, you'll see that one of them completely corroded out, but we didn't see it because it was actually behind the gland collar. It was within that assembly. So here's where this collar should be. Here's where you can actually see one of the 2 bolts, and it's corroded down to nothing. So this was going to fail anyway. The sequence of events that I just said earlier really in this case didn't matter. It was just happenstance that we had all the personnel around it, and it failed at the time. And good thing that nobody got seriously hurt, but the water ended up, once the seal broke off, the water sprayed out from the pump, hitting the bearing housing and then spraying out in all directions. So our operations foreman was standing within 2 feet of that and ended up getting hit. The temperature of that water in the system is at 220 degrees. So a couple things that went right. 911 was called. We had 3 people in the area, actually, since they were trying to scramble to get the pump back on quickly. The communication was great. The operators on the floor ended up communicating with the control room, which then dialed 911, so everybody had good conversations back and forth in a timely fashion. Nobody wasted any time. The fire department knew exactly where to show up. We had a garden hose in the area, which was actually a very good thing in this case, because the foreman was able to run up to it and hose himself down to cool himself off. And then also in the area we had a welding blanket, which they ended up using to throw over the spraying water coming out, so then they can actually isolate the pump and shut it down to stop the spraying from continuing. So from this event, we had some recommended actions, and one of them was to go through the preventative maintenance plan and make sure we capture things like this in more detail. We need to do a better job in inspecting all the equipment, the valving in this case it says, but also the pumps, the seals. We're going to end up instituting tags to show the valve alignment or orientation, whether it's closed or open. This way the operators would be able to react quicker. And then we'll also develop some standard operating procedures to make sure that our workers aren't in the blast pattern if something should go wrong. Basically get them further away from the equipment on startup. And that concludes my section. So with that, Sue.
Good morning. I know that a bunch of you probably got this, I know you got this presentation a few months ago because they gave it to you. But considering that we're in the thick of things right now with heat, we thought it was a good idea to just kind of refresh your memory. So there's 3 primary contributing factors to heat stress. Okay? The first is the environment. So the heat index, the wet bulb test. Are you working in direct sun? Are you working in the shade? Yourself, are you hydrated? What kind of clothes are you wearing? how many layers are you wearing, how you personally respond to heat, and then finally the amount of work that you're doing. If you're trimming bushes, it's one thing. If you're digging out a bush, that's a totally different level of work that you're doing. Okay? So those three factors together will determine how your body is going to respond to heat. So what can you do for the environment? Pay attention to the heat index, to the wet bulb globe test. They say it on the news in the morning. They'll tell you even like for several days before if they know that we're coming into a high heat index time. We get emails. Your foreman should be communicating those to you and then adjusting your work depending on what that level is. We want to make sure that we're completing your heaviest work either early in the morning or in cooler temperatures during the day. And then, unfortunately, there's some people that have to work during emergencies. We try to let's get all the work done in the morning, but if an emergency comes up, you've got to go out there and do work. So make sure that you're taking extra precautions and keeping yourself hydrated and so forth when you're having to do emergency work in the heat. You personally, make sure you're drinking your fluids. If you're out there and you're thirsty, you're already behind the times, right? You should be drinking when you're not thirsty. We would prefer that you stay away from the caffeine drinks, but if that's all that you have to drink, please make sure that you're drinking something. If you're returning from vacation or a long weekend, be aware that any of the adjustments that your body has done to the heat will be stepping back a few steps. So you're fresh to the heat. So make sure that you understand that. Wear light color clothing, wear lightweight clothing. Make sure they're eating properly, getting enough sleep. Recognize early signs and symptoms of heat stress illness. And that's not just for you, because you're probably going to be the last one that realizes that you're having issues. It's going to be your coworkers that realize. So you want to make sure that you know the symptoms so that you can help your coworker and say, hey, you know what, maybe you need to go in, get in the shade, get some water, take a break. Call 911 if it actually becomes serious. As far as the work, we talk about work-rest schedules, and the main thing there is if you have your regular breaks, let's make sure if you're out there in the sun, you're taking your break in a shadier area. If you can get inside to air conditioning, that would be great. Your supervisor, your foreman, is going to determine if it's let's stop the job and take a formal rest break. But other than that, use your breaks, use your lunch to determine your work-rest schedule. Make sure as foreman you're rotating workers, right? If you know it's going to be a hot job and a lot of people, a hot job and a long job, make sure you have extra people that you can rotate in and out. At least work in pairs, right? So you could be looking out for each other, because I can't stress that enough, that you really need to be looking out for each other and stopping each other, even if it's, hey, just get a drink. We have some tools to help you. I'm sure, I've said it many times. We have the job aid cards for heat stress. I forgot to bring any, so if anybody needs any, please either come to me or tell your supervisor and I will get them to you. And for foremen, we do have a heat stress field guide that will detail the different controls that you need to put in place and when. I think it's Quinn. Quinn is going to talk about glove use.
Thanks, Sue. Good morning, everybody. My name is Quinn. So today I'll talk about hand protection, different ways you can protect your hands, either using work planing control or just general PPE. So before I get started, I just thought I'd take a moment to talk about a safety share that I just learned yesterday that was just sent to me. So this happened at Los Alamos National Lab. During startup activities for radiological work being performed at the lab, the team members noticed that the nitrile gloves being used for the work had expired. The job was immediately paused, and all outdated gloves were set aside for disposal. So I thought this was a good example of a group that actually took the time to put work planning control in place, put the right PPE in place, but they still ran into issues. So I just thought this was interesting because after a long time of doing the same job, you still have to take the time to really look at your PPE, look at your controls, and make sure that everything is good in place. So to get started, I could stand up here and give you a bunch of statistics and try and scare you with that stuff, but I think we all know that your hands are incredibly important for your job and everyday tasks. You know, they say that hand injuries are the second most common type of injury at work besides back injuries. They're 1/4 out of all workplace injuries are a result of an incident, and they're mainly caused because either you're not wearing the right type of gloves or you're just not wearing gloves at all. So because our hands are so important, we use them in every single way possible, they're pretty much exposed to every type of hazard there is out there. And at Argonne, we got them all. So we have skin absorption, we have chemical burns, which is another type of reaction your skins have to chemical exposure, thermal, cut, electrical, name it, it's all. So before you start looking at your type of PEP, the most important thing you want to do is work planning. So you can do that by first thinking about where you're placing your hands. It's probably the most important thing. Being aware of pinch points, moving, rotating parts. And if you do decide to go with gloves, make sure the gloves are the right size, the right type for use. And then obviously there's some tasks where you don't want to use gloves. For example, if you have rotating parts, moving machinery where your hands can get caught. So you've decided that you are going to use gloves for the type of job you're going to do. After you've tried every other means, whether through elimination or engineering to prevent your hands from getting into dangerous areas, you can use tools or just any other type of engineering controls. The next thing you want to do is determine what type of gloves are going to best fit for the job. So that's looking at how much dexterity you need to have, whether you're going to be handling small objects, whether you're going to be handling dry or wet objects, what type of cut resistance, if you're going to be exposed to chemicals. Often an issue that people run into when they're picking gloves is they just don't have the right fit. So if you go into a job and you find a pair of gloves you like, make sure you try them on before you start the job, because you don't want to be going to that job and realizing halfway through that your gloves just aren't working out for you. And then the last thing you want to look at is all the different types of hazards, because often types of gloves can protect you from one or up to maybe 3 or 4 different types of hazards. So a cut-resistant glove might also protect you from chemicals, or an abrasive glove might also protect you from cuts. So I'll just kind of go through the different types of gloves and what you want to use to protect your hands from them. So the most popular type of glove is probably the leather gloves. These are good for sharp objects, abrasive objects. Next we have cut-resistant gloves. These have actually gotten better with technology. The polyester gloves are good for resisting water and quick drying. The nylon gloves are good for abrasive resistance and also provide good dexterity. But one thing that's important to keep in mind is that the cut-resistant gloves and the leather gloves aren't going to protect your hands from either crush hazards or really sharp objects. Like if you're handling needles, they're not going to protect your hands from penetration. Next we have impact-resistant and anti-vibration gloves. Impact-resistant gloves are really cool because if you're sticking your hand somewhere where you can get knocked around by something, they're going to protect the back of your hand from bruises and hard impacts. And then shock-resistant anti-vibration gloves are also great because if you're working with machinery for a long time, you really want to protect your hands from the hazards of vibration. Obviously, there's the cloth gloves. These are good for just the light duty work, mostly protecting your hands from getting dirty and slight abrasion protection. You also have insulated gloves. These are good for high temperatures. And lastly, I'll touch on chemical resistant gloves. So in the example I brought up first in the lesson learned, one of the main things to point out from that is that they identified that the gloves were expired. So often nitrile gloves have a 5-year retention life, so after 5 years you want to toss them out. But another test you can actually do is if you take the box of nitrile gloves and you take out the first 2 gloves and then take out the third one and then test that out, stretch it out, put it on your hands, move it around. If it busts then that's a sign that you just need to throw the entire box out. Because often those top 2 gloves are exposed to the environment the most, so those are the 2 that are going to get, they're going to go bad the quickest. So anyways, chemical resistant gloves are going to vary depending on how thick they are. The thicker the material, the higher protection your hands have, but obviously the worse dexterity you're going to have. And I don't know a whole lot about chemical gloves in detail, but I would always refer to the safety data sheets or just consult with an SME to get more information on choosing the right gloves. And then lastly, I'll just mention that ANSI has established a lot of different classifications for cut-resistant gloves, abrasion-resistant gloves, and chemical gloves that rank them all into different levels. So you can often look at the glove. If it doesn't have a label on it, you might be out of luck because there's some gloves that have the label that show the classification. Some of them even have the expiration date, but often that information isn't on the gloves. So it's important to take a look at the box, look at the ordering history, and collect the information from there. So I've actually got a number of different glove samples in storage. So if anyone's interested in trying out different gloves, I've got all different types of gloves, all different sizes. You can just contact me, and I can come over to your area, and you can test them out. And any other questions, I'd be happy to answer.
All right, about 6 weeks ago, I was approached, as was Rob Lang, and they indicated to us that they would like us to go out to Idaho National Laboratory sponsored workshop for MMH. Now, MMH stands typically for Manual Material Handling. Once we got out there, we figured out that the incidents that were happening across a lot of the DOE facilities were not manual. So it was necessary at that point in time to reconfigure our thought process on what MMH means. So we just used the same acronym and changed manual to material. Now, Oak Ridge National Laboratory, Idaho National Laboratory, us, and others have had a number of different incidents related to material handling. And when these incidents occur, they have the potential for catastrophic events. Out at Idaho, and I will talk a little bit about that incident in particular, but I want to tell you a little bit about the workshop as we go forward. One of the things that we learned real quickly is with human performance improvement, you can't change the human condition, but you can change the environment, that the humans work in. And so that we had to kind of, figure out this is what we were going to do as far as this entire workshop. This workshop had approximately 70 people in it, so it wasn't small by any means. There were about 19 entities represented, a lot of different DOE facilities, as well as some private industry, ones that we can call on for help. Interestingly enough, not only were those individuals there, but DOE was there and the DOE Office of Enforcement. And you say, well, why were they there? They're quite concerned. They're quite concerned because a number of these different incidences have occurred, and you could just about take and transpose or interchange any of the laboratory's names and the event following would be very similar. For example, we had a situation here where a small base, high center of gravity mill was being moved, and 3 skates, which was what Hillman recommended for these equipment movers, and this thing toppled. Were we lucky? Darn lucky. Was Idaho National Laboratory lucky? Yes, you'll see that in a little bit. So one of the things I'd like to instill in your mind is that assume 100% probability of failure. Many times we safety individuals, we're looked at as being like Debbie Downers, you know. Every time you go to the safety guy, he thinks of every scenario that could impact that job task. And yeah, that's what we do. That's what we're supposed to do. That's what we're trained to do. But the fact of the matter is, we have to, all of us, with every task that we do, think of 100% probability of failure. Only after you do that are you going to be able to get your head wrapped around the corrective actions that can, utilize or yield a successful outcome. So one of the things we looked at out there, as I mentioned before, yes, we have mechanical material handling issues. So really, if you take like from a 0 to 10, from the lower end and the negative numbers up to 0, those are all covered by ergonomics. Lifting correctly, using your legs, not your back, etc. Getting close to the load. We said, no, that's not what we need to focus on. That's not what's hurting us or potentially hurting us. And then we went all the way up the scale, say to about 10, and said, well, fork trucks and cranes, they have their own standards, and we pay attention to those. So let's eliminate those and just focus on things like dollies, carts, air skates, mechanical rollers, or anything that would have that type, maybe an engine hoist type of a thing. It's not truly, hoisting and rigging type of equipment, but it's something that you can move. Now, all of our DOE facilities have this type of action going on almost on a daily basis. So you can see the frequencies out there. We need to really get a handle on this. The biggest problem that was unearthed as we were going through this workshop was the fact that it was skill of the worker. Skill of the worker all the time. How many of you in here have had job tasks where they said, oh, that's skill of the worker, and then you think to yourself, you know what? I've seldom, if ever, done this, or maybe I have never done this type of a job task, and all of a sudden, it doesn't fit under skill of the worker. So think about that, not only for these types of events, but for any other job tasks that you do. Do you truly have the skill set that's going to make you successful in that job? If you don't, you say to your supervisor or foreman, hey, you know what? I'm not sure about this. We all need to take a step back and look at this a little bit closer. That's exactly what happened at the Idaho National Laboratory. It was under skill of the worker. Had they used skates before? Yes. Very frequently? No. And we'll get into that a little bit. I'm going to come back to this in a little bit again and rephrase just so you hear it twice. If you have any moves that have a high probability of failure, and I already said we have 100% probability of failure in all, get in contact with Rob Lang, get in contact with Mike Dwyer, get in contact with the Critical Lift Committee. This stuff is all free. We'll help you, we'll assist you, we'll advise you, and we'll go forward that way rather than just, hey, I can do this or get it done type of an attitude. That's a good attitude to have, but it can also have some real detriments. So let's talk about this incident. There was an obsolete mill to be moved out of the building by riggers under skill of the craft or skill of the workers. And in some of the other laboratories, they call it skill of the craft. So I put that up for everyone's benefit here. Narrow base and high center of gravity, a recipe for disaster, I'm telling you. They used an overhead crane to lift this off of an elevated area so they could get it down to the floor level. And then they used 3 Hillman's equipment skates, which, by the way, is exactly what the manufacturers of those skates recommend, that you use 3 as opposed to 4. Any of you who have ever moved anything with 4 things, you get some deviation in the levelness of the floor, and you end up chasing one of those skates because it comes loose. All right? Later, they learned that the wrong type of skates were utilized. And remember, the base of these mills generally are cast, and so there's just a narrow area like this, and it's hollow underneath. You lose one of those 3 points, and that stool's falling over, in this case, the mill. The mill made the entire trip through the building while slowly turning around the center core of the building. It was one of these buildings like we have similarly out here, where they had to keep inching this thing around. They were positioning the last 6 inches, just the last 6 inches, trying to get it in alignment to exit out the overhead door in an inside dock area. The corner skates slipped, kicked out from the mill, and the entire mill fell over. Came very close to crushing the rigger who was between the mill and the overhead door and the adjacent passage door. And when I show you this and you see how close it was, you'll say, they were lucky. These individuals, I want to tell you, were the guys that were involved. They were not coerced. They were not asked. This was not rehearsed. This is their true emotional feelings about what took place there, or what could have taken place.
It was a crappy day. Almost lost 2 people that I really care about.
We were moving this mill out of the FCF mock-up shop for excess, and once we got it down into the loading dock where we were gonna pick it up with the forklift, we had to turn it 90 degrees.
And we went to turn it that last 6 inches, the left roller kicked out from underneath and the machine tipped over. And
It just happened so quick when it came over and pushed back, as that I didn't hear any noise or anything like that other than somebody yelling that it was tipping.
I heard somebody yell, "Whoa, whoa, watch out." As I look back, it's coming down towards me, so I don't know how I did it, but I snuck out of the way and barely missed me. It's just a scary feeling. Adrenaline's pumping. It's a horrible feeling to be in that situation.
Started to turn it and it come off and it started rotating. The only reaction that I could had is to put my hand up and start pushing myself backwards. But it pushed me back far enough that the walk-through door, there was a crash bar there, and my back hit the crash bar and the door came up just far enough. I caught enough of it to see the one guy just pedaling it, moving back and hitting the door, and I felt helpless, just not being able to do anything. The only thing I could think of is he okay? Are they okay? Thank God.
I think that moment, I think your breath got taken away, really. I mean, 2 people that I work with every day that have families at home, and That's what was going through my mind, I think, was just that one of them was going to go under it. And yeah, I just couldn't picture telling my wife or my new baby, I guess, at home that I wasn't going to be home that night.
I have a vision in my head, and I still can't get it out, is that we were going to have to pick up two of our people from the ground, either injured or dead.
Say just have respect for the equipment that you're moving and pay attention to your surroundings. You never know what might go wrong, and just communication. Have communication with your coworkers and know what needs to be done.
I think we could have looked at maybe into tearing it down, or perhaps maybe got the right equipment to possibly rig it with the crane. That would have put us in a lot better situation, I think.
I'm glad nobody got hurt that night, or that day, that morning. And I hope this is the last time anything like this happens anywhere in our complexes.
So two of these gentlemen were in our workshop, and the one that was shoved out through the door because his bottom hit that crash bar on that passage door there, he said at one point he saw it was starting to fall. He goes, at the next point I was laying on the ground outside the building in the cold. It was cold at that time when they were doing it. So just sends the right warning, I think, that we need to really start looking at what we're doing when we're doing mechanical material movement. So what went right? Luckily, and by the grace of God, no one was injured. And we've heard that repeated a couple of times here today. Luck. We can't rely on luck. Pretty soon your luck runs out, and then one of our facilities is going to have the big one. Whoops. Lessons learned, these are kind of generic. You can read those. I'm not going to go over them again, but I will tell you this. If you don't have the skill sets in a skill of the worker job that you're doing, you need to get help. If you're moving anything out here and there's any susceptibility that something could go wrong and it could have a serious impact, get in contact with Rob Lang, get in contact with Mike Dwyer, the Critical Lift Committee. Many times in the Critical Lift Committee, we take the lifts, but there's a lot of movement in between before they're set down and it's done. So remember, assume 100% probability of failure in these different types of moves. Do everything you can to mitigate those, and if you need help, by all means get help. Thank you.
Thanks, Steve. So to wrap up, a couple of things I want to reiterate. One, call 911 if it's an emergency, or there's an injury, or you need help. You can also call 911 just to get notification, and it lets the right people know of an incident. Stop, pause, suspend work, have a questioning attitude. If you don't feel comfortable in doing the work, let your supervisor know, stop the work. Everyone here has stop work authority. We have a lot of resources with PPE, wear gloves. They make gloves for all different types of work. We have that resource. If you need PPE, see your supervisor, see your foreman. And lastly, what I want to say is for the next quarter here, let's re-emphasize safety. Take the work authority that you have and think about the work that you're doing. If you're not comfortable with the procedures, how the work is being done, bring it to management. We can change procedures if you think the procedures are wrong. In some cases, we have to modify our procedures. We want everyone to be safe. We don't want to have a serious incident. As Steve said, We're lucky. A couple incidents that we had recently, the injuries were minor, but they could have been catastrophic. Could have been a fatality, and we avoided that. We obviously want you to come to work and do your work safely and be able to go home to your family and friends in a safe condition. Lastly, I want to thank you for your attention this morning. There is a sign-up sheet outside. We'd like you, if you didn't sign it on the way in, sign it. And we will be available up here up front if you want to discuss this topic or any other topic. So thank you and have a safe day.